Talking about electrical safety, we should understand that there are certain things that really matter. Okay, so we're going to write the types of hazards first, and usually they will ask you this. The first type of hazard would be, second please, hello, hello, damaged, yes, हाँ, हाँ बाकी सबको आ रही है, yeah, okay. Okay, so now, so it could be damaged insulations. Damaged insulation means that sometimes what you do is, uh, when you look at a wire, which is like somewhat like this, right? And the wire is like this, and then uh, maybe a plastic covering is there on the wire, but then from some places the plastic covering gets worn out because of a bend or something like that. So basically if you touch it, electrical current can leak out from here, so that's damage insulation. Then the other thing is that it could be a cause of basically overheating cables, and usually overheating cables are when, suppose you're running, when we are running appliances that require large current and wires are thin. So if the wires are too thin and the appliance is drawing large current, then of course it will cause overheating. It might be one, and this is one of the reasons when you put too much load on a certain circuit that cannot take it, so it will heat up and then it will cause fire. And usually fire due to circuits happens this way, and the whole buildings can burn down. So that's very important. And the third thing is the damp conditions. All right, so damp conditions could be like, suppose, for example, if we use wires in a lawn or near a swimming pool. So if you do that, of course, it's like damp conditioning. There's water everywhere, and water can conduct electricity. So that's one of the biggest hazards, right? Then what we do is we also basically use overloading of plugs, extension wires, on a single or multiple socket. Now this is basically that happens in mostly in Pakistan. People do that, and I got to show you basically a picture of it, so you guys know how people do it, and that's very dangerous. So you never do that, because then it will cause loss. It might cause loss of life. It might cause loss of property and other stuff. So don't do that. So overloading of sockets. Let me show you this so you guys can see yourself how we treat ourselves sometimes. You guys can hear me clearly, right? Yes. Yeah, like this, So this picture is a very good depiction of how people do that, and it's not something you should do, because that will cause a lot of drawing of excess current, and then that current might, just be extremely, say, it will make the wires hot or the extension to melt, and then the current can leak and may cause um, all like the first two conditions. So that's not good. You should remember that. Okay, so you can write this down, and then we're going to continue. Okay. Okay. So, yeah. Hello Zainab, how are you? Now, what I want you guys to understand is that okay, both. Okay, hello Najaf, you also joined. That's good. Okay, so up till now we have learned, Najaf and Zainab, that basically there are certain safety hazards when it comes to electricity. So first of all, the hazard damage insulation. So if the damage, like it gets worn out, so you can touch it, that is a big hazard. Then if you put a lot of load, or maybe there's an appliance that draws a lot of current, but the wire is too thin, then the wire is going to melt, might cause fire. And then dam conditions are like if you're putting something near water body, like in a lawn, maybe in a garden or a swimming pool, that's gonna affect it. And then sometimes people overload stuff like this, which is also very dangerous. You should never do that. So that these are four safety hazards that we should always keep in mind. Now, before we get to fix these things, let's talk about how basically electricity works and how is it coming into our houses. So, what happens is that when you basically look at your house, there are three main wires that are coming. So the first wire, I'm gonna put it with red. Oh, it came out black. That's not fair. Okay, so the first wire is the live wire. The purpose of a live wire is to bring current to appliance. Okay, so this is the purpose of a live wire. And then you have a neutral wire. This one is neutral. And and why we use neutral wire is to complete the circuit, because we want current to come and current to go back. That's why. And then we have another wire, which is, I wanted a brown color, but let's just do it with purple. That would do. Another wire is basically a wire that basically takes back current, though. Let me just draw it another way.
Earth wire.
Yeah?
Earth wire.
Yes. How do you know? Okay, that's
Sir,
pretty.
it actually catches current when if it's like a short, like if the current is going like required level, say, like it's coming more than the required level, then the current would go down towards the earth, and then it's like there is a circuit breaker on a or a fuse. It will like.
Okay, yeah, all right, I understand. You're gonna go to the, it will blow the fuse. That's correct. Okay, very good. So, current earth wire is basically a safety wire, and the reason we put an earth wire is to make sure leaking charge may go through it, and I'll tell you how in a bit. All right, like that. So these are the three wires that come in and go. So when in 10 minutes when the meeting ends, please everybody, you got to join the same link again. For Zine, is everything clear? Hussein? Moiz? Chavez?
Yes, sir.
Okay. Yusra and Caroline, do you guys understand everything? Anaya, Ali? Okay. Najaf, everything is clear so
Yes,
far?
sir.
Zainab?
Yes.
Okay, that's good. That's very good. All right. Now, so what are we going to think about? Like, for example, now let's talk about how we can actually make ourselves safe, right? So the first line of defense that you have is a switch. The symbol of a switch, we have already done it, but it's like this. So this is when it is open, and when the switch is like closed, it's like touching. This is closed switch. So what you guys need to understand is that suppose this is like my new PS5. Oh, somebody changed my. Okay, that's not bad color, but I don't want this. I want brown for some reason. Wait a second. Brown. Okay, this doesn't look brown to me. Yeah, this looks brown. Okay, fine. So it didn't change it. Never mind. Okay, so suppose from one side we have like live wire coming in. This is my PS5, okay, new one. And then from one end it's going back, and the current is like going back from here. This is the neutral wire. So the question is, where should I put my switch? So who's going to tell me that?
Would it be between the live and neutral?
Between live and neutral? Okay, like here.
Yeah.
Then how are we going to turn on our PS5 then?
No, sir, it will be between live wire and neutral wire.
But that's what she said.
So it will be on the left side.
It will be on the left side. Here.
Like live wire, neutral wire on the left side of the
No, sir,
wires.
it will be joined together. The switch from live wire and neutral wire.
Oh wow! So basically, so it will be joined together like that. So what purpose will the switch do? The current is still going. No, we are going to put the switch on the live wire. Now, why do we have to put the switch on the live wire? The reason is, so we're going to write the reason. We're going to say that when the switch is open, which means like this, okay, there must be no access to current to the appliance. Do you guys understand this? Now suppose if I had put like the switch here and not here, then what would have happened, that up till this point the current would be available till this point. So anytime if somebody, like there's a problem and the charge is leaking inside, everybody touches it, he's going to get electrocuted, right? Do you guys understand? So we want the current to stop before it enters the the appliance. So that is the reason we have to put the switch on the live wire. Do you guys understand this?
Yes.
Very good, excellent. Now let's talk about then something like called fuses and trip switches. All right, so a trip switch and fuse are basically something like an electrical component, which you might have seen as trip switches or circuit breakers are basically the same thing. Yeah, that's true. So we're gonna first look at fuse, and then we're going to look at trip switches. Okay. Well, okay, let's do it together. Fuse or trip switch. Trip switch, other name, is also wait a second, please. Hello.
Circuit breaker.
Yeah. Wait. Hello. Hmm. Okay. Okay. Thank you. Okay. Now let's talk about this. So first of all, let's look at fuse. A fuse symbol is something like this, a box with a wire going in, right? So what exactly is a fuse? Fuse is basically an electrical component that has a thin wire in it. If a large current flows, its wire melts, disconnecting the whole circuit. Do you guys understand this?
Yeah.
Yes.
Okay. Now, before we get into this, I just want to tell you, fuses have certain ratings. So let's suppose if you want a certain fuse for yourself and you go to the shopkeeper, you're like, okay, please give me a fuse. He's going to ask you, what rating fuse do you want? So you say, the fuse rating I want is maybe 3 ampere, 5 ampere, 7 ampere, 13 ampere, and so on. Like, so their rating. What it means is that a rating would mean that a 3 ampere fuse will melt if a larger current than 3 ampere flows through it. So it's very important that you should know what kind of appliance you're using, and you have to use the right fuse for that. All right, is it clear? All right, so as soon as the meeting ends, which is going to be in like 10 seconds, so please everybody, I want everybody to rejoin. Okay, all right. Okay. Wait a second, let me just do this. Okay. So now, so I was saying that a 3 ampere fuse will melt if a larger current flows, a larger than 3 ampere current flows through it, and that's very important to understand, right? On the other hand, we have a trip switch. So let's talk about a trip switch then. A trip switch is basically an electrical component that disconnects a circuit as soon as large current flows through it. However, unlike a fuse, it can be reset after the current normalizes, which means sometimes there is a problem at the back end, and then there's a large current flowing, and then suddenly a large current flows to your house. So they just, to keep everybody safe and your appliances safe, it just trips for a moment, which means it's disconnected the circuit in your house, and then you can just switch it back on after it normalizes again. So that's how it works, right? However, we will look at the design of this after we've done magnetism, but right now I just want to show you how it looks, right? So it looks like circuit breaker. Basically, you might have seen these in your house, right? I think you might have seen these. They look like this. It's in everybody's house. So if you haven't seen this, probably you should go search right now, like after the class, and probably you're going to find it. Okay, so let me just move the picture a bit here. No, I don't want this. Sorry. Like this. Okay. Is everybody clear about it? Any questions? Okay. Now what you're going to do is, you're going to say, all right, fine, and say, this whole thing, right, is also applied on, suppose this is the appliance. Wait a second, please. Why? Okay, I'm sorry. My iPad just started, updating the stuff. So just a second. You guys can hear me, right?
Yes.
Okay. Okay, let it sync. Okay, so suppose now we have this appliance that we basically want to protect, and then you have the live wire coming in like that, and then you have a neutral wire which is going out like this. This is live, this is neutral. And then you also need to put an earth wire. What is this happening? For some reason, I don't know why it is disconnecting. Wait a second, please. Okay. So, so I was saying basically, you have to put an earth wire because it's important. So let's suppose that for some reason there was a problem here, and because of that, current was leaking inside this. So you want to protect yourself. So where do you think we should put the fuse or the trip switch? On the live wire, on the neutral wire? What do you guys say?
Live wire.
Yes, correct. So we are supposed to put it on the live wire because we don't want, the current if it disconnects to reach the appliance. Now, as soon as this happens, so all this current will be drawn towards this, and there will be large flow of current that will go through this, and it will melt the wire inside, resulting in disconnection of the whole thing, right? So that's what you need to remember. Okay, you can draw this, and I'll be back in a minute. Okay, now that's good. So basically that would trip. Now, so then the question is, which is the right fuse to use, right? So we're gonna do a question. For example, 3 ampere, 5 ampere, 7 ampere, and 13 ampere fuses are available. So an appliance has a resistance of an appliance has a resistance of, just a second please. $36 ohms and is working on 220 volts. So suggest the right fuse to use on the live wire. So that's the question. Okay, now thinking about this then, so we okay, the principal equation that we have is V is equal to IR. We want to find the current. So 220 volts is our voltage. We want to find the current, and the 36 ohm is the resistance. So the current on this is going to be let me take out the calculator. Where is it? Okay, here it is. So it is going to be 220. Sorry? 6.11 ampere is the current, right? Now these are the fuses that we have. So what do you guys think I should use?
7 ampere.
7 ampere? But why?
Because 3 to 5%.
Yes, that's correct. So basically, if I use, less than 7 ampere, if I use, let's suppose 5 ampere, suppose. So it would be basically it will blow. Uh-oh, my spelling of blow is so bad. Okay, it will blow as soon as it is placed, because the thing is that the appliance needs 6 amperes, so you got to have greater than that. And if we use a bigger one, which is 13 ampere, then it will not blow even if a larger current flows that might damage the appliance. So if they ask you, why are you using this? So this is the reason that you do not use too large or too small, because too small will not work at all, not even for a second, and too large is not going to protect you at all, because large current can still go through it. So that's why. All right, is it clear?
Yes.
Yeah.
Okay. That's great. Now, okay, so Zen, everything is clear. Rabia, do you understand everything? Soha,
Yes, sir.
Anaya, everything is clear 100%? Okay, very good, very good, very good. All right, Yusra, what about you? Are you learning something new today? Okay, yes, okay, that's good, Yusra. Now, so,
Sir,
yes.
could you explain a trip switch again?
Yes, yes. So basically, trip switch is like, it has like you can turn it on and off anytime. All right. The idea behind this is that basically, when you connect it, if there's a large current that flows, so basically it's going to trip it. Trip means it is going to disconnect the circuit. Do you understand what I'm saying?
Yes, sir.
And it does it automatically. We learn how it does it in once we've done magnetism, but it does it automatically. But then, if let's suppose there was a large current flowing because of some problem, maybe in your house, maybe outside, and then it trips to save your appliances or your house, wiring and stuff. So when the current normalizes again, the problem is taken care of. You can basically turn it on again. Do you get my point? Now the problem
Yes.
with fuse is that once it is blown, you cannot just you know put the same fuse. You have to buy a new one. So that's a hassle, right?
Yeah.
So trip switches, you don't need to buy them again. You can, set and reset them whenever you want. Understood? So that's the difference between two. The function of both of them is the same. That if a large current flows, you gotta stop it. Understood?
Yes, sir.
That's very nice. All right. Now, so nowadays you might see a lot of things are made using plastic or insulators like rubber and stuff. The reason is that we want to save some cost, and to save some cost, we use double insulation. Now, it really depends on what kind of appliance you're using, right? So, basically, the outer casing of a wire or an appliance is made up of insulators like plastic or rubber to reduce the cost of using a metal earth wire. So what you do is, like, I'll show you a double insulated wire and you'll understand what I'm really, in fact, I'll just draw it first. So let's suppose if there's wire, like there's a wire like this, there's a wire like this, right? You want to insulate them. So what they do is, you might have seen that they put a plastic covering above it like this. And then on the other wire, they also put another plastic covering like this. And on top of it, they put another plastic covering. So that basically, even if one plastic covering is worn out, it's still, protected by the other one. That's basically double insulation. Nowadays, you might see electric kettles, although it's a kettle, but electric kettles are all made of plastic. You might see them like this. They have a base like this, so they're all plastic because we want the casing to be double insulated every single time. I'm going to show you this too, so you guys have an idea what I'm talking about. So double insulation of wires first. For some reason my internet is like super slow today. I don't know why. It's not good. Why won't you search it? Okay, now it did. So double insulation looks like this, as you can see. So you might have seen these are like very common and it's like everywhere. If you really want to look at it, you need to peel off a wire from your house. Your mom won't like it, but then, all right, for physics you can do it. Okay, like that. Okay, so this is basically sort of an example of a double insulation that I was giving you. Now in case that there's an issue, like for example, there's an appliance that cannot have plastic outer covering, all right. In case an appliance cannot have a plastic cover, then we must use an earth wire. Now, so basically how it is used is like, so this is your appliance and suppose live wire is going in and then neutral is going out and there is a leaking of current because of problem and there is no earth wire. Okay, so one guy walks up to it and now if he touches it, so what is going to happen is that all this current is going to go through his body into the ground like that, and probably he won't like it, and then he's like shocked. Okay, now the problem is to solve this, if this is a metal case, that's when this happens. And usually when you're using a computer or a PC which has a case like that, so you should always be looking at that. Now with the same thing, let me just copy this up. Okay, for the same thing, if we put a earth wire so instead of going through our bodies, which are basically naturally an insulator, the current will now prefer to go through the earth wire to the ground, and this way we can basically, even if we touch the whole thing, we won't be shocked. like that. Is it clear, everybody?
Yes, sir.
Safe from shock as the
Yes.
leaked current moves through the earth wire. And that's very important, right? So remember, although it is something expensive, because all metals are expensive, but then if you use it, then it's something really good for you, because then you save yourself from getting a very bad shock. And usually in metal casing we do that, so always remember that. Okay. Okay, so I hope everything is clear now. If you have any questions that you have, please you can ask me. Otherwise, we're gonna see each other tomorrow at 9 p.m. Pakistan time. I'm just changing it for tomorrow and day after tomorrow because I'm traveling. Otherwise, we have the same time. All right, and the same link. So every time you want to join, you can join. Okay. See you. Bye. Have a nice day.
Okay, sir. Thank you, Doctor.
Okay.